Okay, everyone. So this is part 2 of my review for test 3. And I think we left off on number 7. So let's start with number 8. And we want to solve the following equations. And these are all for x, although, don't expect that to be always for x in this case. So I'll write solve for x for all of these. So the first equation, part A, is just 9 over x equals 14 over x plus 3. Right. This is supposed to be an easy one because in this case you can cross multiply. Right? 9 times x plus 3. Oops. Right. So I'll just write 9 times x plus 3 equals 14 times x. So expand this out. We have 9x plus 27 is equal to 14x. So I guess I ended up on the wrong side here. So I'll put the 14x on the left and the 9x plus 27 on the right. And then subtract the 9x from both sides, giving us 5x on the left, 27 on the right, and just divide by 5. So 27 over 5. And feel free to leave it like that. Although I suppose you can write this as 5.4 as well. I'm not a fan of that, but I'll accept it as long as I see all the work here and you know what you're doing. So yeah, I would leave it as 27 over 5. Okay, so let's move on to part B. So we're still solving for x here. Now, this is not a proportion, right? This left side is not a fraction. It's two fractions that you're subtracting. So you could just subtract the two fractions and then get that as a proportion and then cross multiply. Okay, that's not the way I would do it though, right? Again, if you want to do it that way, that's fine, but it's probably easier, in my opinion, just to multiply both sides by the LCD, by the least common denominator. So notice the left side can factor as x minus 6 times x plus 2, and that's important. So that is our LCD, right? The least common denominator on both sides is x minus 6 times x plus 2. Okay. So if you want to get rid of all the denominators, I would just multiply both sides by the LCD, in this case x minus 6 times x plus 2. But again, only in the numerators. You're not doing top and bottom here. I reversed it, but that's okay. So only in the numerators, right? You're just distributing the numerators. So on the left side, what are we going to get? 7 times x minus 6 times x plus 2. I'll put it in the right order. Over x minus 6. Minus 3 times the same thing, x plus 2, x minus 6, doesn't matter the order, over x plus 2 times 1, right? And on the right side, well, we have 44 times x minus 6 times x plus 2, all over x minus 6 times x plus 2. So yeah, one big mess here, but notice that here the x minus 6's cancel. Here the x plus 2's cancel. And on the right side, they both cancel, right? So what are we left with? Well, notice that all the denominators are just 1s now, right? So this really, we got rid of the fractions, right? That was the whole idea for multiplying by the LCD here, is to get rid of the denominators, right? So now the numerator is just 7 times x plus 2, right? Minus 3 times x minus 6 equals 44. Right? And at this stage, you should be able to solve this, right? Pretty easily. Multiply it out. Right? So 7x minus 3x is 4x. 14 plus 18, 32, right? And that equals 44. So subtract the 32 from both sides. 4x is going to be 12. And then divide by 4. Right? So x is 3. Right. So we got our solution, right? X equals 3. Or is it? Right? Remember, when you have an equation with fractions where x is in the denominator, you also have to worry about the restricted values, right? The restricted values here, what makes the denominator 0 is 6 and negative 2. So these are restricted values. And 3 is not a restricted value. So there's no problem here. X equals 3 is the solution. And if you don't believe me, maybe we should check. So, yep, let's check. Right? If I plug in x equals 3 in the original equation, right? Don't plug it in like anywhere else. Plug it into the original equation, and let's see what happens. We get 7 over, sorry for the mess here, x minus 6. But remember, x is 3, so 3 minus 6. Minus 3 over 3 plus 2. Does that equal 44 over x squared? So that's 3 squared minus 4 times 3, minus 12. Right, so that's still a big question here. This is 7 over negative 3. So negative 7 over 3 minus 3 over 5. Does that equal 44 over, so 9 minus 12 is negative 3. Negative 3 minus 12 is negative 15. So, yeah, I guess the question is, right, is negative 7 over 3 minus 3 over 5 really equal to negative 44 over 15? So a couple ways of answering this. One way is to subtract the two numbers on the left, the two fractions. Notice that the LCD here is 15, so if I multiply by 5 over 5 and 3 over 3, what do I get? I get negative 35 over 15 minus 9 over 15, which now that they have the same denominator, it's negative 35 minus 9 over 15. Negative 35 minus 9 is negative 44 over 15, and that's what we were looking for. So the answer is yes, they are equal. And so x equals 3, we checked it, and it works. It is the solution. Okay. Yeah, so again, a bit of a challenge, but that's the way this works, right? If you did it the other way by first subtracting the two fractions, getting a common denominator that way, and then cross-multiplying, you would get the same answer, but I don't think it's any easier. It's still the same problem here, right? All right, so that's 8b. And I was going to skip C, but let's do it quickly. C is more like part A. It's a proportion. You have a fraction on the left and a fraction on the right. So this is something you can cross-multiply. So you get x minus 4 times x plus 3 on the left, and that has to equal x minus 1 times x plus 2 on the right. So not much choice here. We got to expand all this out, multiply it out. You're going to get x squared minus 4x plus 3x is minus x minus 12. On the right, you get x squared plus 2x minus x is plus x, and then minus 2. All right, so bring everything over to the left. In fact, you can subtract the x squares from both sides, and they both cancel. So this is really just a linear equation again at this point. Negative x minus 12 equals x minus 2. Subtract the x's from both sides, you get negative 2x minus 12 equals negative 2. Add the 12 to both sides, you get negative 2x equals 10. Now divide by negative 2, and you get negative 5. So x equals negative 5, or does it? So let's check. Yep, so if x is negative 5, we get negative 5 minus 4 over negative 5 minus 1. Does that equal negative 5 plus 2 over negative 5 plus 3? All right, we get negative 9 over negative 6. Is that the same as negative 3 over negative 2? So notice a negative divided by negative is positive. Same thing on the left. So 9 over 6, is that the same thing as 3 over 2? And the answer is yes, because 9 over 6, right, is 3 times 3 over 3 times 2, but 3 divided by 3 is 1, so that's just 3 over 2. So you're just reducing the 9 over 6 to its lowest terms, 3 over 2. So these are equal, which means it's not a question anymore. We know for sure that this is the correct solution, negative 5. All right, moving on. All right, part D, which is a lot more like part B, right? The left side here is not a single fraction. So cross multiplying is out. If you try to do that, it's just not going to work here. Okay, so we'll do the same method that we did in part B. We'll multiply both sides by the LCD. So I'm just going to copy this down. X over x plus 2 plus 4 over x minus 2 equals x squared plus 6x plus 16. You could try to factor this, but I don't think it's going to work. It's the denominator you have to factor, and in fact that's just the difference of squares, right? So x minus 2 times x plus 2. So our LCD is just x minus 2 times x plus 2, and that's what we're going to multiply both sides by, but only in the numerators, right? So we're multiplying the left by x minus 2 times x plus 2 over 1, and on the right, oh, I didn't leave myself enough room here, x plus 2 times x minus 2 over 1. So that's going to get distributed. And in fact, on the right, the x minus 2's cancel and the x plus 2's cancel. So on the right side, all you're left with is the, oops, I didn't mean to switch colors. Right, the right side is still just x squared plus 6x plus 16. Oops, that's a 6, not a b. Because, yeah, the other factors canceled. On the right, however, we have to be a little more careful. This is going to be x times x plus 2 times x minus 2 all over x plus 2, and then plus 4 times x plus 2 times x minus 2, this time all over x minus 2. So kind of a mess, but notice that we can cancel something on the left as well. We can cancel the x plus 2's for the first fraction, and then the x minus 2's in the second fraction. So on the left, we still have x times x plus 2 plus 4 times x plus 2. Wait a minute. Boy, I almost missed it here. It's not, right, it's not x times x plus 2, it's x times x minus 2 plus 4 times x plus 2. There we go. And that's going to equal x squared plus 6x plus 16. No reason to try to factor this. In fact, we're going to do the opposite on the left. We've got to multiply all this out, right? So x times x is x squared minus x times 2, negative 2x, plus 4x plus 4 times 2 is 8. All right, so that leaves us with x squared plus 2x plus 8 on the left, and x squared plus 6x minus 16 on the right. Again, we can cancel the x squares just by subtracting from both sides. And for the rest of the equation, I'm going to subtract the 6x from both sides and subtract the 8 from both sides. So I know I'm doing a lot at once here. I'm canceling the x squares. 2x minus 6x is negative 4x, right? And then 8 minus 8 is 0. And then 6x minus 6x is also 0, and negative 16 minus 8 is negative 24. So the equation is just negative 4x equals negative 24, which means we can divide by negative 4, and we're left with positive 6. So it looks like x equals 6. Okay, so again, don't take my word for it. You should check that this is correct, and it is. But I'm not going to work it out. You should check it, just like we did in the previous problems, right? In particular, notice that there's only two restricted values here. It's 2 and negative 2. So the restricted values are x equals 2 and negative 2, and 6 is not a restricted value. So we don't have to get rid of that solution because of that. Okay, so now when you check, you're just checking that we did everything correct here. And trust me, we did everything correct here. At least I think I did. Although I almost messed this up here, this sign here. I was going to make it a plus for no reason. So luckily I caught myself there, but I think this is it. Yeah, I must have made another mistake here because that's not correct, is it? So if you did check, it's wrong. Oops. Yeah, I kind of just checked it in my head. Sorry about that, but this is wrong. It's not x equals 6. It doesn't work. So that means I must have messed up somewhere after all. And I hope you caught it right here. This is a plus 16. Why did I change that to a minus? I do that a lot, don't I? All right, so this is a plus 16. Let me use a different color here to make sure. So let me show you my mistake. This is a plus 16, so change that to a plus 16. This changes to a plus 16, and then 16 minus 8 is positive 8. Okay, so I think everything else was correct. It's negative 4x equals 8, not negative 24. Okay, so that was my mistake. So when you divide by negative 4, you get x equals negative 2. Okay, so that's correct, except it isn't, right? Because that was a restricted value. So, yep, we got x equals negative 2, but because it's a restricted value, restricted means it's not allowed. After all that, that's not the answer either. Okay, so if negative 2 was supposed to be the answer, right, the 6 isn't, but it's a restricted value, it's not an answer, right? And in particular, if you check x equals negative 2, notice what happens right away. In the first denominator, you get negative 2 divided by 0, which is undefined. You cannot divide by 0. Okay, so if that's not the answer, what is? There is no answer. There's no solution. Okay, so that's what happens. If you get a restricted value as one of your solutions, it's not a solution. Or if you check, if you plug it in and you get something divided by 0, then you know that there's also no solution. Either way, the answer to number 8, part D, right, no solution. And on Connect Math, I think they either want the empty set, so the little brackets here, the little braces with nothing in it. Another way to represent no solution is a 0 with a line through it. Either way, these are sometimes called the empty sets. It's the set with no numbers, right? So be careful. It's not 0. 0 would be a solution. 0 would be a number. No solution means no numbers. Okay, so it does not mean 0. 0 is not a solution. Okay, so this is just another way to write no solution. And I think Connect Math might prefer one of these ways. But I'm not picky. You can either write no solution or the empty set. Either way is fine. So that was a tricky one, and I messed up a couple times here, so I think I fixed it, and I think this is now correct. So that's 8D. All right, so I better do part E as well. So 3 over x plus 6 minus x equals 11 over x plus 6. And of course, there's always a x over 1 here. You can always put it over 1. So again, this is not a fraction. We'd either have to subtract the two fractions, right, or just multiply by the LCD. And in this case, the LCD is pretty obvious, right? It's just x plus 6, right, or times 1 if you like. So I'm going to multiply both sides by the x plus 6. But again, only in the numerators here. Right? So x plus 6 over 1 on the left, and x plus 6 over 1 on the right. On the left, it gets distributed, right? So we're going to get 3 times x plus 6 over x plus 6 minus x times x plus 6 over, well, 1, right? 1 times 1. On the left side, well, this is not necessary, but you can write this as 11 times x plus 6 over x plus 6. It's just that the x plus 6 cancels here, right? And it does over here as well on the left. So we're left with 3 minus x times x plus 6 equals 11. Okay, so we got rid of the fractions, but now we got to start multiplying this out. Negative x times x is negative x squared, and then negative x times 6 is minus 6x. That still equals 11. Okay, so this is looking like a quadratic equation, right? I can subtract the 11 from both sides, leaving us with negative 8 minus x squared minus 6x equals 0. It looks a little backwards, so let's put it in the correct order here. Negative x squared minus 6x minus 8 equals 0. But since everything is negative, let's factor out a negative 1. Makes it a lot nicer. We could divide by negative 1 on both sides, right? And we're left with x squared plus 6x plus 8 equals 0. And since I'm running out of space, let me just put that way up here. Maybe not way up there. So I'm assuming you can solve this in your sleep now. You've done this many, many times. Factor the left side. It's just x plus 2 times x plus 4. So when you set those equal to 0, we get two solutions. We get x equals negative 2 and x equals negative 4. Okay. Are they correct? Well, again, we should check. I'll tell you what, I will check the negative 4, leaving you to check the negative 2. So 3 over negative 4 plus 6 minus negative 4. Does that equal 11 over negative 4 plus 6? Okay, so this is 3 over 2 plus 4. Does that equal 11 over 2? Well, 3 over 2 plus 8 over 2 is 11 over 2, which is 11 over 2. So the answer is yes, right? So negative 4 works. And negative 2 also works. Again, I'm not going to check that, but you can do that just as easily. Yep. So this has two solutions, right? So yeah, you have to be careful. Some equations will have one solution, some will have two solutions, and in the previous example for part D, there were no solutions, so that can happen as well. All right, we might as well do part F as well. Right, and this is actually a lot like part E, so I should almost just let you do it. But all right, let's do it quickly. And I'm going to use a shortcut here that we could have used in part E as well. Right? It's very similar in the sense that the left side is not a single fraction. So you cannot cross multiply in the form that it's in. However, right, so in the previous problem, we noticed that x plus 1, or in that case it was x plus 3, I think, x plus 6, right, was our LCD. And then we just multiplied both sides by x plus 1. Okay, so there's nothing wrong with doing it that way. But notice that if I just subtracted the fraction 3 over x plus 1 from both sides, they cancel, and then I'm left with 2x over 1 on the left, and on the right, they have the common denominator as x plus 1. Let me fix that. Right, so if that's our common denominator, I just have to subtract the numerators. 5x plus 8 minus 3, right, which is just 5x plus 5, right, over x plus 1. Right, and now it's a proportion, so now I can just cross multiply, right? So 2x times x plus 1 equals 1 times 5x plus 5. Right, so just cross multiply. And on the left, we're going to multiply this out. We're going to get 2x squared plus 2x. And there's nothing to multiply on the right. It's still 5x plus 5, right? Okay. So this will be quadratic. Let's take away the 5x from both sides and the 5. So we're going to get 2x squared minus 3x minus 5 equals 0. Standard quadratic equation. Okay. So when we solve that, I guess we have to factor it. AC method works. Let's see, or I think we can do it this way as well, because 2 minus 5 is 3. Yep. So when you set 2x minus 5 equal to 0, you get 5 over 2. And x plus 1 equals 0 gives us x equals negative 1. So again, two solutions, 5 over 2 and negative 1. Right. But again, we should check. And I kind of messed up the original equation here, so let me rewrite it. 3 over x plus 1 plus 2x equals 5x plus 8 over x plus 1. So let's check the 5 over 2. Oh, that's not going to be easy because it's going to be fractions within fractions again. But you know what to do with these, right? Right. All right, so 5 over 2 plus 1 is 3 over 7 over 2 plus, well, here the 2's cancel, so that's just 5. Plus, let's see, 25 over 2, or sorry, equals 5 times 5 is 20, so this is 25 over 2 plus 8 over 1 over 5 over 2 plus, again, 1 over 1. All right, so the left side will just be 6 over 7 plus 5 over 1. And the right side will be, I'm just going to multiply top and bottom by 2 here. I was going to try to add the fractions, but so you're going to get 25 plus 16 over 5 plus 2. All right, on the left side, let's multiply by 7 over 7. So we get 6 plus 35 over 7. And here we're going to get, let's see, 41 over 7. And 6 plus 35 is 41. So 41 over 7 equals 41 over 7. That's certainly true. So there we go. 5 over 2 is correct. What about negative 1? So let's check x equals negative 1. If I plug that in, I get 3 over negative 1 plus 1 plus 2 times negative 1 equals, I'm going to try to do this all in my head here, but it's basically going to be 3 over 0. So 3 over 0 minus 2 equals 3 over 0. We're dividing by 0. That's not allowed. So negative 1 is not a solution. So yep, here's where you have to be careful. You have to cross out the negative 1. Right. Had I done this correctly, we should have noticed that negative 1 is a restricted value. So we could have just gotten rid of the negative 1 right away. So it turns out there's only one solution to this equation. It's 5 over 2, or 2.5 if you prefer, but I prefer 5 over 2. But not negative 1. If you leave the negative 1, you're going to lose points. So again, a very good idea to check or recognize that it was a restricted value, that you'd be dividing by 0 if you left the negative 1. All right, so that's number 8. And now we get on to the applications, the word problems. Okay, so number 9, rather than write it all out, I just copied it from the practice tests. So in a 21-gram serving of Cheerios, there are 170 milligrams of potassium. To the nearest tenth of a milligram, right, so that's 1 decimal place, how much potassium is there in a 36-gram serving? Okay, so there's a lot of ways to answer this question. The best way, though, is to set up a proportion. Right. So we have 21 grams of Cheerios. So let's write that out, Cheerios. And in a 21-gram serving, we have 170 milligrams of potassium. I'd love to abbreviate the symbol K as potassium on the periodic table, but I'll just write it out as potassium. So what we're looking for is the number of grams, the number of grams of potassium, number of milligrams of potassium, so I'll call that X, in a 36-gram serving of Cheerios. Okay, so yeah, write out the equation. Very important to write out the equation. But, you know, we can cancel the units on both sides, essentially. So the equation is just 21 over 170 is equal to 36 over x. Right. So since it's a proportion, we can cross multiply. Right? We get 21 times x equals 36 times 170. And this is where we need a calculator. Right? So I get 21x equals 36 times 170 is 6,120. So divide by 21, and my calculator says 291.42855714, something like that. But we're rounding to the nearest tenth of a milligram, so that means we can cut this off at 1 decimal place. Right? I mean, you would have to round, but the 2 doesn't round up, it rounds down. So 291.4. So how many milligrams of potassium are there? 291.4 milligrams of potassium. If I can spell it right. It's an A. Yep. Right. So that's the answer for number 9. Okay. So again, you set up the proportion, set up the equation, and solve the equation. That's the only way I would accept an answer here. Okay. So if you don't write down the equation, yeah, I can't help you. Right? There's a lot of shortcuts to doing this, but in my opinion, just setting up the equation is not that hard. Right? And there's other ways of setting it up too that are correct. So if you didn't set it up this way, you could do it another way, right? You could say 21 grams of Cheerios over 36 grams of Cheerios, right, is going to be 170 milligrams of potassium over x grams of potassium. So different equation, right? But when you cross multiply, you end up with the same thing here. Okay, so yeah, there's other ways you could set up the equation that would work, but you have to set up the equation. All right. And number 10 is very similar, so I'm going to go through it quickly. We have 39 grams of sugar. I'll just write out sugar in a 355 milliliter, you can abbreviate, milliliter of Coca-Cola, right? So to the nearest tenth of a gram, how much sugar, so X grams of sugar, in a 2-liter bottle of Coca-Cola. Okay, so this is kind of a trick question. 2 liters is not the same as, a liter is not a milliliter. So 2 liters is 2,000 milliliters. Okay, so yeah, there's 1,000 milliliters in 1 liter. So 2 liters, right, would just be 2,000 milliliters. The units have to match, right? Okay, so now the equation is really just 39 over 355 equals X over 2,000. Right. And again, there's other ways you could set this up. You can also set it up by saying 39 over X, right, is equal to 355 over 2,000. Right. Either way, when you solve the equation, or when you cross multiply, you get the same equation. 355 times X equals 39 times 2,000, which is, if I get out my calculator, 39 times 2,000 is 78,000. So divide by 355. And what you get is, okay, so this is 219.7183, but again, we're rounding to the nearest tenth. So X is going to be 219.7 grams of sugar. So, yeah, roughly 220 grams of sugar in a 2-liter bottle. All right, so that's number 10. All right, number 11. To estimate the height of a tree, a student measures, sorry, there's a little typo there, measures the length of the shadow cast by a 2-foot tall vertical stick to be 4.5 feet. Right. The length of the shadow cast by the tree is 76.5 feet. And the question is, how tall is the tree? Okay. So at this point, maybe a picture might help. So here's the ground, right? Here's my tree. Right. And we want to know how tall the tree is. So we're looking for the height of the tree. I'll call that h. And we know the length of the shadow, so there's a shadow here. I don't know what color the shadow is. Say that's the shadow. And we know that this distance here is 76.5 feet. And so we want to know how tall the tree is. Okay, well this information is not enough, right? What we also have is a 2-foot stick. We stick in the ground, so this is 2 feet tall, and that shadow is a little bit longer. It's 4.5 feet. So what we have here are 2 similar triangles, right? We have the big triangle, and the ratio of the sides there is the height h over 76.5 feet for the shadow. Right? So this is the height divided by the shadow. And then for the stick is 2 feet tall, and the shadow is 4.5 feet. Right. So there's your equation. Now we just have to solve it. And again, we can solve it just by cross-multiplying. So 4.5 times h is equal to 2 times 76.5. Again, I got to break out my calculator. So 76.5. Oops, not doing it right. 76.5 times 2 is 153. So 4.5 times h is equal to 153, it's a 5, and then divide by 4.5. So h is equal to, looks like 34. Try that again. Yep. 34 what? Feet, right? Everything's in feet. So the height of the tree is 34 feet, right? And we know that just by measuring the length of the shadow of the tree and measuring the length of the shadow of a stick that we know is 2 feet, right? 2 feet tall. So yeah, find the height of the tree. How tall is the tree? The answer is 34 feet. Right, that's number 11. So now we get to a hard one, number 12. It takes 7 hours for an experienced bricklayer to build a large wall. An apprentice would take 9 hours to build the same wall. How long would it take, rounded to the nearest minute, for an experienced bricklayer and 2 apprentices to build the same wall? Okay, so again, we're going to make a table here, and the equation we want, right, is let's see, the amount of work, right? So the rate of work, right, times the time is equal to the amount of work that gets done. Okay. So build a little table here. Right. So first of all, what do I mean by rate of work? How quickly one works, right? So for the experienced bricklayer, it takes 7 hours to build the wall. And so, right, how much of the wall gets built in 1 hour is 1/7, right? 1/7 of the wall per hour. Let me try that again. Right, so this is for the experienced bricklayer. We also have an apprentice, right? So how long does it take the, let's see, so what are we looking for here? The amount of time it takes for an experienced bricklayer and 2 apprentices. So let's give that a name. Let's call it T. So let T be the amount of time for bricklayer and 2 apprentices. To build the wall. Assuming it's a wall of a house or something, right? It's only 7 hours, so that's just one side of a house, maybe. All right, so that's we're calling that T. Right? For the apprentice, right, it would take 9 hours for the apprentice. So in 1 hour, that's 1/9 of the wall per hour. And actually, we have 2 apprentices. So if it helps, we'll have a 3rd row here for the other apprentice. That's also 1/9 of the wall per hour. So that's how quickly the apprentice works. Right? So they're all doing the same amount of time, T for each. So when we multiply, we get 1/7 times T. That's the amount of work the experienced bricklayer does. And 1/9 times T for the apprentice, and 1/9 times T for the other apprentice. when you put them all together, you add them all up, they're building one side of the house, one wall, right? So you're just adding all these up, right? This is t over 7 plus t over 9 plus t over 9 equals 1. So that's the equation we have to solve. So what's our common denominator here? How about 7 times 9, right? 63. So what I'm going to do is just multiply both sides by 63. Let me just copy down the equation first. Equals 1. So 1 times 63 on the right, and then 63 on the left. So you're going to get 63t over 7 plus 63t over 9 plus 63t over 9. And that's going to equal 63. All right. But 63 over 7 is 9, so that's 9t. 63 over 9 is 7, so 7t plus another 7t. So let's see, 14 plus 9 is 23, right? Or 16 plus 7 is also 23, I think, right? And that's going to equal 63. So divide by 23, and I think we have our answer, right? It's 63 over 23 hours. Did they say how far to round? Oh, to the nearest minute. So they're not looking for hours, they're looking for minutes, right? So 63 divided by 23 is about 2.73913 hours. But how many minutes is that? How many minutes? Well, how many minutes in an hour? That you should know. Right, so this is hours. You know in 1 hour, there's 60 minutes. Cancel the hours. So it's just 2.73913 times 60. And when you multiply 2.73913 times 60, you get about 164.3478 something minutes. And we're rounding to the nearest minute, right? Yes, to the nearest minute. So 164 minutes. We can lop off the decimal here. 164 minutes. Or if you prefer, what is that going to be? That's going to be 2 hours and 44 minutes. Okay. Yep, I'm not picky. 164 minutes or 2 hours and 44 minutes. Yeah, I mean, again, if you're wondering how do I get the 2 hours, 24 minutes, remember 2 hours is 120 minutes. So if you take away the 120 minutes, you get 44 minutes as the remainder, right? So 120 minutes plus 44 minutes, that's your 164 minutes. A little sloppy there, but so either way is fine, right? Yeah, so again, not an easy one. Again, if you make the table to get the equation, again, the equation is critical here. You have to get the equation and then solve the equation to get the answer. Right? No, right? Don't just guess. Right? That's not a good. I mean, look, sometimes guessing is a good method in some cases, not very often. Right? You don't want to guess your answer. You want to go through the process step by step here. All right, number 13. Okay, number 13. It would take Devin 7 hours to paint the house alone. It would take Floyd 10 hours to paint the house alone. How long would it take Devin and Floyd to paint the house if they worked together? So this is a more reasonable problem. And we want to round the answer to the nearest hundredth of an hour, which is a weird unit. We can also convert to minutes or seconds, but you know, this should make it a little bit easier, right? So whereas number 12 was kind of a hard problem, this one should not be that bad. But it's the same idea, right? You have the rate of work, right, times the time. and that's going to equal the amount of work that you do. So just make your little table here, right? And there's only 2 people in this case, right? There's Devin and Floyd. Okay, what's the rate of work for Devin? Well, if it's 7 hours to paint the entire house alone, 1/7 of the house per hour. Right? And then for Floyd, if it's 10 hours to paint the entire house, 1/10 of the house per hour. And what are we looking for? Again, I'll call it T. Well, let's call it X. I guess it doesn't matter, right? So let X be the amount of time they paint the house together. Right, working together. Right. So that's just X for both. So the amount of work for both is 1/7 times X for Devin, 1/10 times X for Floyd. When you add them up, you should just get one house, right? Right. So there's your equation. Now you just solve it. And again, there's a couple ways of doing this. This is x over 7 plus x over 10 equals 1. So your LCD here is 70. 2 times 5 times 7. Yeah, I think it is 70 here. Yeah, 7 times 10 is 70. So just multiply both sides by 70. Both on the left and right. Left and right, not top and bottom. Okay, so on the left side, when you multiply this out, you get 70x over 7 plus 70x over 10 is equal to 1 times 70 is 70. But 70 over 7 is just 10. 70 over 10 is 7. So 10x plus 7x, 17x, is equal to 70. So now just divide by 17. So there's our x, right? 70 divided by 17. And this is in hours, right? This is in hours. So that's how long they take, Devin and Floyd take to work together to paint the entire house. And let me just bring up a calculator. 70 divided by 17. And I get 4 So this is approximately 4.1176 hours. But we only want 2 decimal places, right? The nearest hundredth of an hour. So that's 4.12 hours. Yeah, that's the answer they're looking for, right? Rounded to the nearest hundredth of an hour. So it takes 4.12 hours to work together. Yep, if you're curious, it's about 247 minutes, which is also what, 4 hours and 7 minutes. Right. Yeah, I mean, look, I guess I would take that as well, except I'm ignoring the directions. The directions say hundredth of an hour. So 4.12 hours is our answer here. Right. And that should make sense. After all, if it takes 7 hours for Devin to paint the house alone and Floyd 10 hours to paint the house alone, when you work together, it should take less time. That's the whole idea of cooperation, right? When you do it together, it takes less time overall, right? So yeah, the answer is not 17 hours. You don't add the times, right? If it takes 17 hours for them to paint the house together, they're doing something wrong because, you know, that each one of them takes less time to paint the house separately. So then just paint the house separately, right? Have Devin do it, and it only takes 7 hours rather than 17, right? So yeah, you don't add the times. What you add is the amount of work that each one does separately. Okay, So again, very much like the last problem, when you have a work problem like this, make a table, do the rate times time equals work, right? Add up the amount of work each, and you're usually just doing one job together. In this case, right, the 1 here stands for one house. They're painting one house together. Makes sense? All right, moving on to 14. 14. A small pump can fill a pool in 1 hour less than twice as long as a large pump. If two pumps were working together, they would fill the pool in 6/5 of an hour. Okay, 6/5 of an hour, right? How long would it take the small pump working alone to fill the pool, and how long would it take the large pump? All right, well, we're looking for the amount of time, right? So let's let S be the time for the small pump to fill the pool. Right, by itself. And then let's let L be the time for the large pump to fill the same pool, again by itself. So S and L. All right, so again, it's a work problem. They're working together. So this will be rate times time equals work. Just make your table. Right. Again, 2 rows, I think, and 3 columns. That's the usual, because we have the small pump and the large pump. Right. All right. So what is the rate of work? Oops, we need to do that. What is the rate of work for the small pump? Well, the small pump can fill the pool in 1 hour less than twice as long as the large pump. What does that mean? So it doesn't say the small pump can fill the pool in 1 hour. In fact, it's 1 hour less than twice as long as the large pump. Right? So the small pump can fill the pool in 1 hour less than twice the large pump. Right? So 1 hour less, you subtract 1 hour, right? And then twice as long as the large pump is 2L. So 2L minus 1. Okay? So we really don't need 2 variables here. We don't need an S and an L. Once you know L, you can find S by using this equation here. Okay? So that's what the first statement says, that S and L are related, and the amount of time it takes for the small pump, it's not twice as long as the large pump. It's 1 hour less than that. So it's 2L minus 1. Okay, so that should help. Okay, now what? If it takes 2 pumps working together, I'm sorry, if the 2 pumps were working together, they would fill the pool in 6/5 of an hour. Okay, so yeah, the amount of time for both would be 6/5 of an hour. So that's the time. Let's just write 6/5 here. Or if you like, you can write 1.2. Either way is fine, I think, because we are talking about number of hours here. So 6/5 or 1/2. So it's the same time for both because they're both working together. Okay. The rate of the small pump is just 1/S. Right? The time is S, so the rate is 1/S. And for the large pump, it's 1/L. Okay? So that's the rate, not the time. But remember, S is equal to 2L minus 1. Let me try that again. My pen's not working again. Okay, so let's try that. S is 2L minus 1. So 1/S is 2L minus 1. So if you multiply 1/2L minus 1 times 1.2, you get the amount of work for the small pump. Right. And for the large pump, it's just 1.2 over L. And again, you can also write this as 6 over 5L. Right? You can write this as 6 over 5 times 2L minus 1. I hope that's not too small. I'll write it bigger over here, right? So 6 over 5 times 2L minus 1. Right? And then for the large pump, the amount of work it does is 6 over 5 times L. So when you add those up, you should get one pool. Right? When they work together, they're filling one pool. So there's the equation. Maybe let's write it correctly here. 6 over 5 times 2L minus 1 plus 6 over 5L is equal to 1. So solve that equation and you have the time for the large pump, and then once you have that, you can find the time for the small pump. Okay. So yeah, what's our common denominator here? Well, if we multiply this out, we get 10L minus 5. I'm not even sure that was necessary, but yeah. So what's our LCD? I guess that's the question. Right, so we have a 5, we have an L, and we have a 2L minus 1. So multiply them all together, and that's our LCD. So I think what I'll do is just multiply both sides of this equation by the LCD. Right. So I just copied this down here, and we'll multiply both sides by the least common denominator. And the reason for doing that, right, this is not a proportion anymore, right? This is not one fraction, it's 2. So cross-multiplying, at least in this form, is out of the question. So, yep, I'm going to, that's why I copied this down here. I'll do it down here. Multiply both sides by 5L times 2L minus 1. Yeah, 5L 2L minus 1. And that's going to get distributed here. So 6 times 5 times 2L, times L times 2L minus 1. All over 5 times 2L minus 1. Plus 6 times 5 times L times 2L minus 1. All over 5L. And that's going to be 5L times 2L minus 1. Over 1. Right. Okay. One big mess, but I think we can cancel the 5s. We can cancel the 2L minus 1. Here we can cancel the 5s and the L. And nothing cancels on the right, but it's already over 1. So all the denominators are now 1s. So that should make this a lot easier. We have 6 times L plus 6 times 2L minus 1 equals 5L times 2L minus 1. So multiply this all out. We get 12L minus 6. And on the right, we get 10L squared minus 5L. Right, so I know I should have used an X for the large pump, but too late now. All right, so let's keep going. We have 18L minus 6 equals 10L squared minus 5L. So I'm just giving you a moment to think about that. Right, this is going to be a quadratic equation. So let's get 0 on the left. 10L squared minus 5L minus 18L plus 18. So that's going to be 10L squared minus 23L plus 18, which is a quadratic equation. Right, and yeah, normally the 0 is on the right, so I'll put it on the right here. Ignore that. So we have to solve this quadratic equation. So it means we should be able to factor. At least I hope this factors. So the AC method, right, GCF is 1. The 23 is prime, so the GCF is 1. So A times C is 10 times 18, which is 180. So we're looking for two numbers that add up to 180, that multiply to 180, but add to negative 23. So that means they're, ooh, I'm running out of space here too. So that means they're both negative. So it's not negative 1, negative 180. It's not negative 2, negative 90. It's not negative 3, negative 60. Or negative 5, negative, what's 180 divided by 5? I don't know, I should be able to do that in my head. 36. Yeah, that's not even close, right? We're looking for negative 23. So it's not negative 6 and negative 30. It's not negative 10 and negative 18. That's 28, negative 28. It looks like it's, I'll write it way up here, negative 12 times negative 15. Oh no, that's 27. Oh, I thought that would work out. Yeah, so I don't think this factors. All right, so I must have messed up again somewhere here. Yeah, it has to factor. If it doesn't, then there's, I mean, whatever solution this equation has, it's not going to be pretty. So where did I mess up? So 6L plus 12L is 18. That part's fine. Oh, this is 6. I don't know why I changed that to an 18, but that's my mistake right here. So this is wrong. Let's fix that. Yep, so this was supposed to be 18L minus 6. So we were supposed to add 6 to both sides. So this should have been a 6 here. So yeah, the equation we were looking for is 10L squared minus 23L plus 6 equals 0. All right, now let's see if that works. All right, so same AC method. All right, so A times C is now 60. That makes it a little easier. So what two numbers multiply to 60 and add to negative 23? Well, I think I can see it, right? Negative 3 times negative 20 is positive 60, and negative 3 minus 20 is negative 23. So when you split this up, it becomes 10L squared minus 3L minus 20L plus 6. And factor by grouping, so you get L times 10L minus 3. And then minus 2. Yep, I think 2 is the GCF here. So this is 10L minus 3. So when you factor the 10L minus 3, you get L minus 2 equals 0. So L is either 3/10 or 2. So which one is it? I'm going to go way back up here. Well, if L is 2, right, then S, the small pump, would be 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. So that makes sense, right? It takes 3 hours for the small pump and 2 hours for the big pump, the large pump. So small pump is 3 hours, and then the large pump is 2 hours. Right? Because it's a bigger pump, it works faster. It takes less time. Now, what about the 3/10 here? That's not going to make sense, right? And I'll show you why. Well, I have no room to do this, do I? All right, so L is equal to 3 over 10. So what would S be? S would be 2 times 3 over 10 minus 1. So 6 over 10 minus 10 over 10 would be negative 4 over 10. So it would take a negative amount of time for the small pump. That doesn't make any sense, right? Time is positive, not negative. You can't go backwards in time, right? So again, apologies for a lot of little mistakes here, but I think we got our final answer. The small pump takes 3 hours to fill the pool. The large pump takes 2 hours to fill the pool. And that answers the question. Yeah. So again, one little mistake here. Kind of messed it up. At least I caught it. All right. So that's number 14. I think we can go on to number 15 now. All right. Try not to mess this one up. Sorry about that. So number 15. On a day when the wind speed is 25 miles per hour, a plane can travel 682 miles with the wind in the same amount of time that it can travel 572 miles against the wind. Find the speed of the plane in still air or with no wind. Same thing. So let's just call that, I don't want to use S for speed. How about P for plane? Let P, well, let's just use X. All right, I'll use P. So let P be the speed of the plane. But with no wind. Right. If there were no wind, that would be the speed of the plane. We'll call it P. All right, so here, remember the equation is a little bit different, right? This is going to be speed times time equals distance. Right. So here's my little chart, little table, little matrix, if you will. Right. And what do we have? We don't have two different planes. It's the same plane, but one is going with the wind, and then it turns around and it travels against the wind. So those are the two situations. And if you remember, the speed of the plane with the wind is P plus W. But notice we know what W is here. W is the speed of the wind. Right? That's given to us. Right? That's the wind speed is 25 miles per hour. So W is 25. Right? So it's not P plus W now, it's P plus 25. Right? Going against the wind, right, it's slower, so you subtract P minus 25. The same amount of time that it travels, so going with the wind, going with the wind here, it's 682 miles. So that's the distance. And then going against the wind, it's 572 miles. Okay. Now, I left off the time. How much time does it take to travel that distance? Right, tricky. They don't tell us that, right? They don't tell us. All they say is that it's the same amount of time for both. So let's call that T. We don't know what T is, but it's the same for both with the wind and against the wind. All right, so this might be a little confusing because, right, we don't know what T is. But let's write the equation, right? This is going to be P plus 25 times T is equal to 682. For the bottom equation, you're going to get P minus 25 times T is equal to 572. So we have two equations, right? But we still have two variables. Okay, so here's what I would suggest, right? Divide by the P plus 25 here on both sides. Right? So when you do that, the P plus 25 cancels and you're left with T equals 687 over p plus 25. No, not 687, sorry. That was a 2. That got crossed out. So 682 over p plus 25. Right? And do the same thing with the second equation. Divide by p minus 25 now, so that they cancel on the left. And now t is going to equal, it's the same t, right? 572 over p minus 25. So it turns out we don't care what t is. This is our equation, right? And we can solve for p, right? And in fact, it's a proportion, so we can just cross multiply, right? So 682 times p minus 25 is equal to 572 times p plus 25. Let me make sure I have the numbers right. 572, 682. Okay, I think that's right. So now just use a calculator, multiply all this out. You get 682 times p minus 682 times 25, 1750. 17,050. So that's going to be 572 times p, and then plus 572 times 25, 14,300. All right. So again, I think you can take it from here, right? You're just going to take away the 572p from both sides. And we might as well add the 17,050 to both sides. Okay, so on the left, 682 minus 572 is 110, p, right, plus 0, equals 0p plus 14,000. I should be able to do this in my head, right? We are adding these, we're not subtracting them, right? So 0, 5, 3, 1, 3, 31,350. So 110 times p is equal to 31,350. Now just divide by the 110. And I do need a calculator for that. Looks like 285. Right. Remember that's p here. So 285 what? Miles per hour, right? So 285 miles per hour. Feel free to abbreviate. So that's how fast the plane can fly if there was no wind. And I know that looks like an S, doesn't it? It's 285. All right, 285 miles per hour. So that's number 15. All right, last word problem, number 16. Janine rides a bike 30 miles in 1 hour, less than the time she could jog the same distance. So let's try to process that, right? Janine rides a bike 30 miles in 1 hour, less than the time that she could jog the same distance. She rides her bike 8 miles per hour faster than she jogs. Find the speed of Janine jogging and riding on the bike. All right, so let's see. Let's give these names. So let B be the speed on bike, and let, well, J for jogging, not for Janine, because there's only one person here, right? So J is the speed for jogging, right? And I'll come back to the first sentence, but the second one is a little bit easier, right? She rides her bike 8 miles per hour faster than she jogs. Right? So whatever the speed is of jogging, it's going to be 8 miles per hour faster on the bike. So B is J plus 8. So we don't need a b here. Instead of b, it's j plus 8. So this is the speed on the bike. Okay. Now, it's the first statement that we got to really be careful about here. Janine rides a bike 30 miles in 1 hour, less than the time she could jog the same distance. All right. So what does that mean? It means that the distance, okay, so we're talking about distance here, right? So the distance is 30 miles, and the amount of time, it's 1 hour less than the time for jogging. Right, so the bike time is the jog time minus 1? 1 hour less, yes, minus 1. Okay. Okay, so far? Okay, now I know this is a little confusing here. So let's call the jog time t. Or we could call that the bike time, but it doesn't matter. So the bike time is just t minus 1, right, because it's 1 hour less. All right, I think just make a table now. At least that's what I would do, because we got to organize all this information here. So this is speed times time equals distance. And again, it's just Janine. So she's riding her bike or she's jogging. Those are the two situations. And now let's fill in the table. So the speed on the bike is, well, we called that b originally, but remember, b is also just j plus 8. And the speed for jogging, well, that's just j, right? That's what we're calling it. Now the time. The time for jogging is t, and the time on the bike is t minus 1. Okay, what about the distance? There's only one number for distance here, right? That's the 30 miles. So it's the same distance for both, right? So the distance is 30. And now let's just write down the equations, right? We have j plus 8 times t minus 1 is equal to 30. And we have j times t is equal to 30. So two equations, but again, the problem is there's two variables here. So that might be a little bit confusing. All right, so those are our two equations, for better or worse. So a couple of ways you can attack this. I would multiply this out here, right? Let's just FOIL that. So let me rewrite it. J plus 8 times t minus 1 is equal to 30. So j times t minus j plus 8t minus 8 equals 30. But before you add the 8 to both sides, remember j times t, this is equal to 30. So it's the same 30 on both sides, right? So you can subtract the 30 from both sides, and you get negative j plus 8t, and then adding the 8 to both sides equals 8. So 8 times t minus j equals 8. I'm just copying that down here and putting the positive in front. All right, now how does that help? Well, notice that, should we do this in terms of t or j? What are we looking for? We're looking for, the speed would be j. We're looking for j. So we can eliminate t. If I divide both sides by j here, t is really just 30 divided by j. Okay. So this is 8 times t, or 30 divided by j, minus j, equals 8. So 240 divided by j minus j equals 8. We should probably multiply by the least common denominator, which in this case is just j, right? There's only one denominator, it's j. So multiply both sides by j. And when you do that, you get, well, 240 times j over j minus j squared equals 8j. So, yep, on the very left here, the j's cancel. And when you form the quadratic equation, I think you get j squared plus 8j minus 240 equals 0. So that's your standard quadratic equation. We're using j instead of x. Don't let that bother you. So how do we solve a quadratic equation? Exactly. We have to factor. So what two numbers multiply to negative 240 and add to positive 8? Well, so if I divide by negative 12, I get 20. And negative 12 plus 20 is 8. Lucky guess. You know, I mean, I could have gone through this, but each one of these, but I think that's it, right? So j minus 12 times j plus 20. So that means j is either equal to 12, or if we subtract the 20, j is negative 20. But that doesn't make sense. Your speed can't be negative unless you're jogging backwards. Good luck with that, I guess. No, so it's going to be positive 12 here, right? We can ignore the negative. It doesn't make sense for this problem. So that means the jogging speed is 12 miles per hour. I think that's the answer. And oh, we're also looking for the speed on the bike. But remember, that's just 8 miles per hour faster. So 12 plus 8. So the bike speed, right, remember b was j plus 8. If j is 12, then b is 20. So the bike speed is 20 miles per hour, which is indeed 8 miles per hour faster than the jogging speed. All right, so there it is. Not an easy one, but that's how it's done. All right, so that's number 16, and that's about as hard as it's going to get for word problems. In fact, I'd be surprised if there were one that difficult on the test. But you never know. I'm preparing you for the worst. All right, moving on to number 17. Okay, so number 17. Now we're in chapter 8. Determine if the following relations are functions. So are these functions, right? Are these functions? So what is a function? Right, so remember, for a function, for every value of x, there is only one value of y. For every x, there's only one y. Right? So in part A, you can see we have a list of ordered pairs, right? So these are just divided into x's and y's, right? X always comes first, and then y. So what we're looking for, right, do any of the x's repeat? If the x's repeat and give you a different y, then the answer would be no. So what are the x values here? We have a negative 2, a 1, a 4, a 0, and a 9. Are any of those the same? No, they're all different. Right? They're all different. So the answer for A is yes. It is a function. Right? It does not matter that the y's are different here. Right? We have two different x's, but the same y. Right? That's okay for a function. What you cannot have is the same x, but two different y's. Okay. So the A is yes. What about B here? So what are the x values? We have a 5, a 3, a 3, and a 1. Now those are not all unique, right? The 3's are the same. So we have the same x, right? But we have two different y's here, 2 and 7. Okay, so when x is 3, y is 2, or y is 7. That's two different y's for the same x. That cannot happen for a function. So part B is no, this is not a function. Okay, part C. Now part C is a little tricky, but if you solve for y here, y is going to be, let's see, 18 minus 6x over 3. Or if you prefer, it's just 6 minus 2x. So this is just a straight line, y equals mx plus b, right? Something like this. And every x has only one y. It satisfies the vertical line test. So the answer to part C is also yes. Right. D. D is also a line, but it is a vertical line. When they're saying x is 4, they're saying x is 4 for every possible value of y. So, of course, the y's are all going to be different for the same x. Right. So part D is definitely no. It is not a function. E, however, is a horizontal line. Horizontal lines are functions. Every x has only one y. Right? So part E is yes. This is a function. Right? You have a lot of different x's, but the same y. That's okay. Right? What about part F? So part F, they give us the graph. And I guess for the graph, let's do the vertical line test. For these vertical lines, do any of these vertical lines cross more than once? Nope, just once for each. So this is definitely a yes. It is a function. What about G? If I draw a vertical line, does it cross only once? Nope, it crosses twice. Once here, once here. So that's not a function. Part H, vertical line tests. Every vertical line crosses just once. After all, this is just a straight line, and it's not a vertical line, so it is a function. Okay, so part A is yes, part B is no, part C is yes, part D is no, part E is yes, part F is yes, part G is no, and part H is yes. Right, that's all it is. Right, number 18, find the domain and range of the following functions. So here we're assuming they're functions, and we just want to find the domain and range. So you have to know what domain is and what range is, right? So domain, we're looking for the x values, the x coordinates, and the range we're looking for the y values, the y coordinates, right? And at least in part A and B, when they're given as x and y, right, x comes first and then y. All right, so for part A, we'll do the domain first. It's just a set of numbers, the x's, -3, 1, 4, and 2. What about the range? So those are the y values, right? Oops. So that's going to be 2, 5, 0, and 5. We already have the 5, so it's just these three numbers here. Okay, for part B, I'll do that up here. What's the domain? Just all the x's, 8, 2, and 0. Right. The order does not matter. If you want to put them in order, 0, 2, and 8, that's okay too. And then the range, well, we have a -4, and a 1, right? You don't have to repeat the negative 4. That's redundant, right? It's just negative 4 and 1. I mean, it's okay to do it, but it's better just to write each unique number, each distinct number. All right. Now, part C is a little bit trickier. So let's do part C down here. So they don't give us the set of the set of ordered pairs. They give us all these, the graph, right? So there's a whole bunch of points here. Oh, I guess I should do that, right? There's this point here, which looks to be something like negative 1.8 and 4. So the points, we're not going to be able to list them all, right? So for the domain, I'll do it this way. We're going to use interval notation. Where are the x's? The x's go all the way from, looks like negative 5, and it stops right around 8. So from negative 5 to 8. Again, that's a 5 to 8. Right. So that's it for the domain. Now you might be asking, why am I using brackets? Why not parentheses? So parentheses means that you're not including the negative 5, and you're not including the 8. Okay, why are we including them? Because this point is actually part of the graph, right? It's not a circle, it's not a hole. If it were a hole, then you can make a case for using the parentheses, right? But because it's an actual point, oops, we're using the brackets. Right. All right, what about the range? So for that, we're looking at the y values. What's the smallest y value here? Looks like negative 2. And the biggest y value looks like 7 to me, right? So negative 2 to 7. And we do include both the negative 2 and the 7. Okay, so that's part C. And then part D, okay, this will be a little bit trickier. So what about the domain? So we're starting, again, those are the x's. So we're starting over here on the left. Looks like negative 8. And it's a point, so we do include the negative 8. And we go all the way to right around here, which is negative 5. But hang on, right? Remember, this is not a point here. Right? This is a hole. So we're not including it. So this is why we would use parentheses, right, around the negative 5. Let me try that again. Parentheses, right? All right, then what? Then we skip over a bunch of points here, and we start again at negative 2, and then we go all the way from negative 2 to, looks like 6, right? And here we do include both the negative 2 and the 6. Oh, sorry, if we include them, we use brackets, not parentheses. So negative 2 to 6. Okay. And it's traditional to join these in a union, right? So we use the U in between for union. Okay, so that's the domain. The range, well, those are the y values. The smallest y value is, looks like negative 4. And the biggest y value here looks like 5. And we include those both. So again, negative 4 to positive 5. Okay, so that's domain and range, either from a set of ordered pairs or from the graph. Okay. Okay, number 19. Find the domain of the following functions and express your answer again using interval notation. All right, so for part A, we'll just do one by one here. Part A, we have the function f of x equals 3/5 x minus 9. And you should recognize this as, you know, a linear function. It's just a straight line. Y equals mx plus b, right? M is 3/5, b is negative 9. But here we just want the domain, right? Remember, the domain has something to do with the denominator. you better make sure the denominator is not 0. So I can write this as 3x over 5 minus 9 over 1. And the denominators are 5 and 1. But those are not 0. Right? See, the x only appears in the numerator. X could be 0, but then that would be 0 minus 9, right? It would give you 9, negative 9. Right? As long as the denominator is not 0, then there's no restricted values. Right? No restricted values. But that means the domain then is everything. Right? All real numbers. In interval notation, you're going from negative infinity all the way to positive infinity. So that's the interval notation for all real numbers. Okay. Part B. G of x is, I'm just rewriting it, x squared minus 9 over 2x minus 10. So we're finding the domain, which again just has to do with the denominator here. Right? If we wanted to find the restricted values, what would we do? We would take the denominator and set it equal to 0. And you can solve that in your sleep, right? Add the 10, divide by 2. So 2 times x equals 10, divide by 2, and we get x equals 5. Okay. But be careful, that's not the domain. That is the restricted value. Right? The domain is everything else, right? In other words, all the x's that are not equal to 5. So what x's are those? So here's the number line, right? Here's 3, 4, 5, 6, 7. I hope that's not too dark. Everyone can see that. So we just want to make sure we get rid of 5, but everything less than 5 is okay. And everything bigger than 5 is okay, right? So this is x is less than 5 or x is greater than 5. So what would that be in interval, what would that be in interval notation? Well, you're going from negative infinity to 5, right? That's everything less than 5. Or, so union, from 5 to infinity. So that would be the interval notation for the set of all real numbers that are not equal to 5. What are we including? We're including everything less than 5 or everything greater than 5. Got it? So that's the domain in interval notation for part B. Part C is a little trickier, so I'm gonna copy that down here. So I think that was h of x, right? So this is still 19c. H of x is x over 4x squared minus 1. Right. So again, find the domain. Right. So we don't care about the numerator here. Just take the denominator, set it equal to 0, and solve for x. Right. Again, we're looking for the restricted values. And then we will throw those out and get the domain. So for the restricted values, we have to solve this equation. So that's a quadratic equation. I think we can factor it, right? We have a perfect square minus a perfect square. So this is a squared minus b squared. So a minus b times a plus b. And so we take 2x minus 1, set that equal to 0. 2x is 1, divide by 2. So it looks like we get x equals 1/2. And then for the 2x plus 1, the only difference is here we're subtracting 1 from both sides. So when I divide by 2, I get x equals negative 1/2. So I get two restricted values, right? 1/2 and negative 1/2. Okay, so those are the restricted values. What's the domain? The domain is everything else, right? So I'm just going to, a little hole here, a little hole here. So we want to exclude negative 1/2 and positive 1/2. So the domain is everything else. Everything, let's see, less than negative 1/2. Right? All of these numbers here. All of these numbers between negative 1/2 and positive 1/2, right? Like 0. 0 is in here, right? 1/4 is in here. All those numbers, right? And also everything greater than 1/2. So all of these numbers as well, greater than 1/2. So in interval notation, you're going from negative infinity to negative 1/2, and then from negative 1/2 to positive 1/2, and then from positive 1/2 all the way to the right, that's positive infinity. Don't forget your U's for union, and that's the domain for part C. Okay, so that's domain given the equation of the function. So take the denominator, set it equal to 0. Right? When you solve for x, you either get no solutions, one solution. Here we got two solutions. When you throw them out, you get the domain. So the domain is all the real numbers that are not the restricted values. Okay. Again, it might be easier to say the domain is the set of all numbers x such that x does not equal negative 1/2 or positive 1/2. So it's the same thing, but again, they want the interval notation. Especially if you go on to college algebra, you're going to have to use interval notation a lot. So get used to it now. All right, and I think that just leaves number 19. So that was number 19, right? So that leaves number 20. All right, number 20, evaluate the following functions at the given values, right? In other words, you're just plugging in. So for part A, we're given a function f of x is equal to x cubed, x to the 3, minus 5. Okay, so remember what this means, right? This is essentially the same as y equals x cubed minus 5, right? Instead of y, they're using f of x. So the one thing I warned you about, right, this is not f times x. Don't read it that way. Don't think it that way. It's not true. F is just the name of the function. Okay, and different functions have different names. Like in part C, we're going to use g instead of f. Doesn't matter, right? So it just does not mean f times x, right? So when they're asking for f of 2, they're not asking for f times 2. What they're asking you to do is replace x with 2. Everywhere you see an x, change it to a 2. Right? So instead of x cubed minus 5, it's 2 cubed minus 5. Right? Now 2 times 2 times 2 is 8, and 8 minus 5 is 3. So the answer for part A is 3. And that's all they're looking for, right? Just the number 3. Right? I mean, you know, they're not asking for x and y. They're not asking for the ordered pair, but the ordered pair would be 2, 3. So, you know, on Connect Math, there might be some problems where they ask for the full ordered pair, the 2 and the 3. Okay, but here they're just asking for the 3 itself. Okay, so don't get confused there. Right, part B. So now the function f of x is 2 over 5 times x minus 3 over 5. And now they're asking for f of 9. So replace x with 9. This is 2 over 5 times 9, right? 9 over 1 minus 3 over 5. Right? So you can multiply these fractions, right? 2 times 9 is 18, and 5 times 1 is 5. So 18 over 5 minus 3 over 5. Well, they have the same denominator, right? They're both 5s. That should be a 5 here. Try that again. So just subtract the numerators. 18 minus 3 is 15, and 15 divided by 5 is 3. So the answer for part B is, well, it's also 3. Coincidence. Yep, so f of 9, can I squeeze that in here, is also 3. All right, part C. So I'm going to scroll down a bit here. This is going to be g of x now. G of x is x squared minus 3x. And they want g of negative 3. So g of negative 3. So again, we're not multiplying g times negative 3. We're changing this x to negative 3. And we're changing this x to negative 3. Right? Both of these x's become negative 3. Okay, so negative 3 squared is negative 3 times negative 3. Right, so that's positive 9. Minus 3 times negative 3, so minus negative 9. Well, minus a negative, right, is positive. So 9 plus 9 is 18. So the answer for C is 18. And just to make it official, g of negative 3 is the number 18. All right, and then part D. So h of x, I'll just copy it down here. H of x is 5, that's a 5 minus 3x. And they want h of 5 over 6. Yep, 5 over 6. So, yep, the point is you don't have to plug in whole numbers. You can plug in fractions. Right? After all, the domain is all real numbers. 5 over 6 is a perfectly good real number. So this is 5 minus 3 times 5 over 6. So if it helps, maybe let's write this as 5 over 1 minus 3 over 1 times 5 over 6. So 5 over 1 minus 15 over 6. But notice the 1 and the 6 are not common denominator here. So we'll suppose the common denominator here is 6. So I have to multiply top and bottom by 6 for the first fraction. I can leave the second one alone. So I get 30 over 6 minus 15 over 6. 30 minus 15 is 15, so we get 15 divided by 6. Or better yet, let's see, 15 is 3 times 5, 6 is 3 times 2, 3 divided by 3 is 1, so they cancel, and you're left with 5 over 2. So after all that, the answer is 5 over 2. Or 2.5 if you're prone to using decimals. But I prefer the 5 over 2. And so, yeah, I don't think I have enough room there. I'll just write it 5 over 2 for part D. All right, so that's number 20. I'll finish the last 4 here. So there's also part E through H. Let's do those down here. All right. Excuse me. Number 20. This is still number 20. Part E, we have r of x equals x over x minus 2, and they want us to find r evaluated at 2. So everywhere you see an x, change it to the number 2. So we have 2 in the numerator, and 2 minus 2 is 0. 2 divided by 0 is not 0. In fact, it's not even a number. It's undefined. There is no such thing as 2 divided by 0. Okay? So the answer I would write officially as undefined. That's the way we describe something that's not a number. I mean, you can say no answer, right? I can spell answer here, right? Or you know, there is no such number. Right? So that's fine, but again, undefined is the correct way to express the answer. Right? Not 2 over 0. 2 over 0 is nonsense. It's meaningless. Okay. So what went wrong here, right? If x is 2, what's y? Well, there is no y. There is no y. And the reason for that is because what's the restricted value? If I take the denominator, x minus 2, set it equal to 0, and I solve for x, I get x equals 2. So 2 is a restricted value. And that means it's not allowed into the function. So the mistake here was plugging in 2 in the first place when it's not allowed, right? 2 is not in the domain. It is not allowed into the function, right? Because it is a restricted value. Okay. So again, don't worry about any of that. The answer is undefined, right? So now let's look at part F. I think I can squeeze it in up here, right? So f of x is 3x minus 1 over 2x plus 12. And we're looking for f evaluated at negative 5. So simple enough, just trade x for negative 5. So 3 times negative 5 minus 1 over 2 times negative 5 plus 12. So everywhere you see an x, just change it to negative 5. And just do the arithmetic here. 3 times negative 5 is negative 15 minus 1. 2 times negative 5 is negative 10 plus 12. Okay, so the numerator is negative 16. The denominator is 2. Right? 12 minus 10 is 2. And negative 16 divided by 2 is 8. Oh, sorry, negative 8. Negative 8. So that's the answer for part F. Yep, this is just negative 8. And part G, you know, I don't think we're there yet. This should be chapter 10. I'm going to do them anyway, but I don't, at least for test 3, I don't think I would worry about these. This is a little bit premature. But okay, I'm going to do them anyway. So part G is square root of 2x. So f of x is the square root of 2x. And they want f of 8. So what is f of 8? Well, you do the same thing. Replace x with the number 8. Right? But it's not 28, right? It's 2 times x, so it's 2 times 8, which is 16. But then they want the square root of 16, which is 4. And if you didn't know that, you can use, right, you're welcome to use your calculator for the square root of 16. So the answer is 4. And finally, for part H, again, this is one I'm not going to expect you to do on this test, but for test 4 maybe. So g of x is 7 minus x. So part H. G of x is the square root of 7 minus x. And if I remember right, they want g of negative 2. Yep. Oh, sorry, that's a typo. It's not f of negative 2, right? It's g of negative 2 here. Right. Which, you know, I guess is just fine because we shouldn't worry about this anyways. Yeah. All right. But we can still do this. It's the square root of 7 minus negative 2. Again, don't get fooled here. It's not 7 minus 2 is 5. It's 7 plus 2, right? Which is 9. It's the square root of 9, which is 3. So that's the answer for part H. So I wouldn't worry about G and H, but certainly A, B, C, D, E, and F are certainly reasonable questions for the test. And it's really just, you know, showing the work, plugging in the numbers, and then doing the arithmetic, the calculations correctly here. Right. So yeah, evaluating functions, as long as you're aware that this notation here, this symbol here, is not f times x, I think you'll be okay. Right? Because you're not multiplying 2 times f. You're not doing 2 times x cubed minus 5. That's not what this means. All right. All right. And that'll do it. And I got it in just under 2 hours also. So I know a lot of questions here for test 3, but the actual test will not be anywhere near as long. I just wanted to make sure I covered all my bases here. And so I did most of the practice tests, and hopefully that's enough review preparation for test 3. So best of luck.